Hey guys, so this is the last set of notes for the units 10 through 12 um, combined units of topics. So you just have this week, the last set of notes, the last practice, the week 3 practice, and then then you'll just have the units 10 through 12 test. Okay, so this one is pretty simple. It's about converting radical forms and exponent forms. So you can see from this example here at the top that when you have x to a fraction, m over n, then the bottom number or the denominator becomes the root of the number, and the top number or the numerator becomes the exponent of the number. And you can also rewrite it so that the exponent is on the outside like this, and the root is on the inside, and that usually makes it easier for you. So when the first question or the first example that it gives you is to write as a radical expression. So if you have t to the 5/8, remember the bottom number becomes the root. So this would become the 8th root of t to the 5th power, and that's how you'd write that as a radical expression. In the next example, it asks you to write it as an exponential expression. So, and remember, the bottom is the one that's the root. So this would be 7 to the 3/4, and that's how you'd write that one. So when you have to evaluate, when it asks you to evaluate, it wants you to give a number and it wants you to break down the base using powers. So let's look at these next couple examples down here. So you have 16 to the 1/4 power. This is the same thing as the 4th root of 16 to the 1st power, which is just 16. Now, when you're thinking about what number multiplied times itself 4 times gets you 16, that number is 2. So the 4th root of 16 is 2, and that would be your final answer there. In the next example, this asks for the 3rd root, if I rewrite this, of 343. So the 3rd root of 343, you can either plug it into a calculator or take it if you know it, is what number times itself gets you 343. And if you do that out enough times, then you should get it is 7 for your final answer there. In the next one, they ask for the 5th root of a negative number. So if I rewrite this, this would be asking for the 5th root of negative 243. And it's important to note that you can actually take the 5th root of a negative number because of the fact that 5 is odd. So if you have an odd root of a negative number, it can be done because you can get a negative number out of that. So think of it instead as what is the 5th root of 243? And if you do that out on the calculator, or you think about what number times itself 5 times gets you 243, that number is 3. And then the negative is just going to get tagged along with it, because if you multiply out that negative 3 5 times, then you will get negative 243. So 5th root, it makes a difference. What root makes a difference? If the root is odd, then you can take the odd root of a negative number. But if you look in the next example asks you for the 4th root of negative 81. Since that root is even, since 4 is even, this cannot be done because that would give you an imaginary number, the I. Okay, so this cannot be done. So for this one, you have to write not a real number. Okay, so that one's your answer there, not a real number. In the next example, we're going to have to break it down a little bit. So remember, the bottom number is the root. So this is the 4th root of 16 to the 5th power. But remember also that you can write it like this. You can say the 4th root of 16 and the entire thing is raised to the 5th power. The 4th root of 16 we just figured out up on the top there is 2. So 2 to the 5th power is 32. And that's how you break it down to be able to get an answer. So you're breaking down the powers to be able to get to your answer. So 32 to the 3/5. Let's try this one. This is the same thing as the 5th root of 32 to the 3rd power. Okay? But it can also be written as the 5th root of 32, and then the entire thing is raised to the 3rd power. Well, the 5th root of 32, if you multiply it out enough times, is 2. And 2 to the 3rd power is 8. So our final answer here would be 8. In the next one, remember that if you ever have a negative exponent, so now the exponent is negative, it's a negative 2/3. When you have negative exponents, what you have to do to make it positive is you have to move it to the bottom. So this can be rewritten as 1 over 125 to the 2/3 power. And then further, it can be rewritten as 1 over the third root of 125 all to the second power. Okay? The third root of 125 is 5, so we have 1 over 5 to the second power, which then becomes 1 over 25 for our final answer. So when you have a negative exponent, you bring it to the bottom. In the next example, it gives you a fraction to a fraction. When you have this, remember that fraction on the outside that acts as an exponent applies to the top and bottom. So it becomes 1 to the 2/3 all over 64 to the 2/3. And then further, you're going to break each of those down. 1 to the 2/3 is the same thing as the cube root of 1 squared all over the cube root of 64 squared. Well, the cube root of 1 is just 1, so we know our top is just going to be 1. The cube root of 64 is actually 4, and then 4 squared is 16. So this one has a final answer of 1 over 16. In the next set of problems on your practice for week 3, we have to have a little bit of a refresher on the product rule and the quotient rule when it comes to exponents. So if you recall, the product rule when it comes to exponents says that if you have a to the m times a to the n, then that's the same thing as a to the m plus n. So you're going to add when you see them being multiplied. And then similarly, if you see a quotient rule where they are being divided, then you're going to do the opposite and you're going to subtract the exponents when they are divided. So let's try it out with these examples. In the first one, they're being multiplied, so you're going to add exponents. So this is the same thing as y to the 1/2 plus 2/5. And remember, when you're adding fractions, you have to find that common denominator. So here the common denominator would be 10. Okay? The top in the first one would become 5, and the top in the second one would become 2 times 2, which is 4. So our total fraction is now going to be 9/10. So you would write your final answer as y to the 9/10 power. Okay? And then that one is done. In the next one, we have u to the 2/3 plus 1/4, because again, we're multiplying. So we're going to find that common denominator. The common denominator here would be 12. So you'd have 4 times 2 is 8, a new top of 8. And then 3 times 1 is 3. And 8 plus 3 is 11/12. So our final answer here would be u to the 11/12 power. Okay. In the next couple examples, you're working on the subtracting because they are two quotient rules. So in this one, I'm going to rewrite this to be 1/4 minus 2/3. Make sure you're always subtracting the top from the bottom. And so you are going to do common denominator there would be 12 again. Our top would become 3 in the first one, and our top would become 8 in the next one. So 3 minus 8 is negative 5/12. So far we have y to the negative 5/12 as an answer, but we're not done yet because negative exponents need to be moved to the bottom to become positive, and we want our answers to be positive exponents. So you get 1 over y to the 5/12. And same thing with the fourth example, we're going to take 1/2 and we're going to subtract out 4/5. Common denominator is 10. So my new numerator is going to be 5 for the first one and 8 for the second one. And 5 minus 8 is negative 3/10. So we're almost done there. We need to write x to the negative 3/10, but that moves to the bottom. So our final answer is 1 over x to the positive 3/10 power. All right, let me know if you have any questions. Good luck.